Yo, this is Math 189, Section 1011, Video 1. All right, so we're going to talk about inclusion, exclusion. All right, so let's see, a few videos for this section, not just one long one. All right. All right, so we're talking about inclusion, exclusion, principle, right? If it was principal, that'd be like the principal of your school, I think. Maybe I just spelled principal of school, I don't know. Okay, anyway, whatever. Inclusion, exclusion. That's what we're doing. All right, so let's start with an example. All right, let's say that A is the set 1, 2, 3, 4, 5. B is the set, let's do 4, 5, 6, 7, 8. Okay. So then we can see that A union B is the set 1, 2, 3, 4, 5, 6, 7, 8. And so therefore A union B is 8. Okay, up here we can see that the cardinality of A is 5. Here the cardinality of B is 1, 2, 3, 4, 5. But here this is not equal to the cardinality of A plus, okay, so that's one more thing. So 5 plus 5 is 10. This is not, 8 is not equal to 10. Oops, definitely not equal to 110 either. So you can see that they're not equal. Okay, so what do we have to do to make them equal? Okay, so we're going to subtract off something. All right, so let's think about what we have to subtract off. All right, so let's say we have A. Here we have B, A, B. A is 1, 2, 3, 4, 5. So we've got 1, 2, 3, 4, 5. And B is 4, 5, 6, 7, 8. 6, 7, 8. All right, so remember that when we did this, right, so the sum of the cardinality of A plus the cardinality of B, this was actually greater, right? This was greater. I'll put greater than or equal. Because it's true, if it's greater than, then it's greater than or equal, right? Okay, so why is that bigger? I mean, in our case, if the or equal is bothering you, just think of it as greater than. Why is it greater? Right, so think about what this counts. Cardinality of A plus the cardinality of B. Cardinality of A, that counts all of this. Cardinality of B counts all of this. Right, so cardinality of A plus cardinality of B counts the intersection. Let's see. A intersect B. Right, what do they both have in common? Let's see, they got 4, 5, right? They have 4, 5. So the cardinality of A intersect B is 2. So this sum, this counts 3, or this counts 3 plus 2 plus 3 plus 2. So 5 plus 5, it counts this 2 twice. Right, so for this to be equal, Remember, this is 5 plus 5. This was 8 here, right? This is 8, 5, and 5. We got to subtract off 2. Okay, so what counts that 2 in general is the cardinality of A intersect B. Okay. All right, so that's the idea. All right, so for two sets, the cardinality of A union B is the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. Okay. All right, so now let's look at 3 sets. Let's look at 3 sets. All right. Okay, actually, before I do 3 sets, let's look at it pictorially for 2. Let's say we have A, and we got B. Okay, so cardinality of A union B. Okay, we'll think of it in terms of pictures now. This again is, we got all this, right? And all this together. Okay, so it equals that. Oh, okay, so what does that equal? Okay, so this is equal to, so all this space together, right, all this space here, this is equal to probably run out of room here, huh? Okay, let me write it like this. Wait, that doesn't make sense, so it's this way. Minus, we'll figure out what we got to minus off, okay? So, okay, so you probably see that, right? How much space do we got here? We got all this space. So if we were to count all this space and all this space, right, we'd be counting this part right here twice. So we'd be counting that little sliver twice, so we have to take that off. So minus just one of those. Okay. All right. So let's do a similar thing with 3 sets.